These are some advantages having 4 different electric motors or more one motor per wheel could have in the future of electric vehicles that we really can't do too much with non-electric vehicles because the wheels are just so much more heavy. First one is that having a bunch of small motors means that the cooling for these motors are better, which will extend their lifespan significantly and mean we have to put less energy into cooling this whole device. That is a huge advantage. Another one is it can make steering much more efficient because we can better put more energy into one wheel or another wheel, or slow down one wheel or speed up one wheel, so we can turn without losing as much energy. And with it having separate ones, we can also design the gears slightly better, so you have to turn less massive gear sets in a whole or big contraption around to be more flexibility to the system. We can turn the wheels more easily, a greater degree, and then when everything is much more connected and with a fast response time. So that not only will it save energy or make sharp turns more possible, which could make parking especially more better or something, it could be really important during bad or inclement weather or during emergency driving, for example. Another one I want to talk about, which is ABS, or there's a couple different other acronyms that are close to it. What it is an idea that when you hit a certain type of surface, you instead of applying the brakes continuously, you apply the brakes and you let it up or down in a certain fluctuation pattern. Particularly that if you see that the car is slipping, the car is moving too fast compared to the wheels, you apply the slipping and hydroplaning to some extent. So you're just like you're on ice or something. So then the wheels are let to spread up again and catch the surface more. However, in reverse, when the car is moving a lot slower than the wheels, you're speeding up this car, so then you have to slow down the wheels. So by using this, you can make sure that you never lose control of the car. Another thing that is often done with this whole thing to further control of a car is that they use a system where in some motorcycle bikes or motorbikes for sports, racing, and more, and a couple car ones, but mostly I'm thinking about motorbikes, they don't always continuously put the same amount of power or speed into the wheel. So a slight fluctuation might put more power or speed quickly in like every tenth of a turn or something. Now this can have a couple advantages. When the wheel is moving slower, it can be more easy for you to turn the whole device. There's less of a gyroscopic effect of the wheel, but the wheel also doesn't grip the surface the same and can freely rotate. But then once you turn it, you want to power up more power to actually get the power to move your vehicle in that direction and not slide. And you can vary it not only with the speed, but the power output in different ways. And this can lead to more controlled turns that's often used in racing, and faster one even at the expense of power, and more efficient turns. All this could be much more efficiently put into an electric motor, which because an electric motor has the ability to quickly change performance much more quickly and over continuous range and much more precisely than a regular engine. If you have each motor separate, it's better than having one motor doing it and with a wider range of control than you could even ever manage with gears and stuff and more automatic. You could even train this with neural networks and computation devices and stuff to work with predictive algorithms that can look at the road surface and predict how much it needs to vary these inputs for maximum efficiency, maximum control, and everything, and safety. Very accurate, because I seem like, is it a slippery surface or not? And then you can have even more fast response back because the electric motor itself can act as a sensor to detect slippage and other things, or how it's turning or something. So really fast, safe response time that makes you anyone practically a pro racer with this tech. Another one is huge advantage of this tech would be continuous transmission. Electric motors have somewhat of ability to give you many more gears continuously with both power and speed than any gearbox could do. Now there is an optimal efficiency that they want at, and you might need gears if you want to keep at a high efficiency below that range, but still many more faster for these quick things I talked about before. But you can eliminate a lot of gears for the same amount of control, which could increase efficiency, safety, and control, and make the riding experiences generally smoother. Another thing that we've kind of already discussed is this whole thing will let you have faster controls, which with a human, which for most of the time it's not going to be a big deal, but there's a couple scenarios where it could be a very, very big deal. Namely, during emergency situations, it can be a big deal also, much more of a big deal once you have AI technology or artificial intelligence or something that takes away some of the driver control, and maybe they could use it to make faster, better turns, which could significantly save maybe a few percent, not a lot of energy over long time, but could speed up commute times and ease of it. And it could also, these faster controls could just generally make your ride smoother. And a smoother ride might lead to less nausea and stuff like that. Maybe, I don't know. For people that are very sensitive to that stuff. A future that I've already talked about to some extent is getting rid of a gearbox to a large extent. And by getting rid of a gearbox, we save a lot of weight, which increases efficiency. There's less parts of wear and tear, which increases safety and efficiency. There's less friction, which increases efficiency. There's less heat, which decreases the amount of need for cooling, which increases efficiency. The complexity goes down, which makes it more serviceable and manageable and easy to replace parts. So a lot of advantages just there. Again, electric motors, particularly small ones, are less maintenance. And we're going to go over again why, over and over again, why it's less maintenance. So that means also that it can last longer. And having longer periods of time where you don't have to maintain it means that you're more or less likely to have it broken down if you have regular checkups. Because if you see it as often, it's overkill. Not only that, is you have a bigger buffer. Instead of having a month period where you might need to check it, maybe you have now 1 or 4 years period we can check it up on it. So a bigger buffer for when you don't have to check on it. Another advantage that's a little hard to see because it gets a little covered up here is it will have a low center of mass. And having a low center of mass because of where the motors are now all located more near the bottom, and having that mass more spread out has a couple of advantages. Also, just having the mass spread out over the whole entire vehicle more. It means that the vehicle is less likely to flip over. And to show you how important that is, the Tesla, with its battery pack being some of the lowest, already is some of the safest car for flipping over when test. And it also means you're less likely to lose control, because one wheel is less likely to raise totally off the ground or something. And in severe accidents, the accidents are less likely to keep rotating stuff, and people are less likely to get severely injured. So that is a very good one. And not only is the center of mass lower again, it's also going to be more spread out once along all the wheels. Another advantage of this whole system that I've kind of glossed over a little bit is that there's going to be less noise and vibration. And why I'm saying that this will happen is for a few reasons. First of all, is that small motors themselves make less energy loss with vibrations and noise and vibrate less. They're also damped out more easily. And the more spread out the vibrations and noise are for the body of car, the easier they are to be damped out, because if they start off at a lower amplitude, they're more easily absorbed than overwhelming and making a whole rigid system get the energy, and then there's less likely to get constructive interference where over time vibrations build up. They're more likely to also not have as much momentum when they start shaking. Now, this might not only is for a smoother, more comfortable dry experience, but it also increases efficiency and decreases wear and tear yet again. Now, the next one is going to sound a little weird, but I just said less push on motors. What that means is that whenever you design an electric motor, there's outward radial forces and other forces that try to push and tear apart the actual motor. When you have four small motors, that becomes much less significant, and you don't have to design it as much and worry about that in design compared to one big motor, which can save on weight eventually, but also can make it last longer and more sturdy. So, another kind of thing that I want to point out is that this could allow for a technology where you have different motors on different parts of wheels. So you could have motors optimized in the back for more push and the forward ones for more speed and ability to turn or change quickly. This will be something you have to more design for each different car, but it could allow for even increased efficiency, control, and safety. Now, you would also have to, the best optimal will be very individual cars, because it depends on how much, oftentimes the car turns, how much weight the car is, how far apart all the wheels are in each different dimension, the center of mass balances, and stuff like that. So it's not as simple as we can just do it for every car the correct way. And as motor technology changes, the pros and cons of different motors will change too. And also like how long you drive and stuff like that, and the amount of battery and stuff like that. Another advantage is you don't have to replace all the motors at once. So if one of them is broken, you can just replace that one instead of one. And if they each have, or with a newer, more updated version, or if an accident happens, it's likely to take down all the wheels. It might take down the center. If in a car with one motor, if that one is doomed, you're doomed. This one, you have to take out much more motors. And also replacement costs could be cheaper because it's not one big motor and easier to do. Another huge advantage of the system that I'm just getting to it is that each wheel now will have more of a different type of terrain on it, more likely, because they're farther apart. Now, I'm not talking about different terrain on a nice, well-made, clean road, but I'm saying if part of the road has frozen ice, you more likely have wheels that are not on the frozen ice with motors on them, which means that they can compensate and fix it. And the more wheels you have, the more likely you have wheels on a good surface, which increases traction and safety and gives you much more control. Another idea that's more futuristic is the more wheels you have, the more data you have in some ways. And by that I mean each of the wheels do collect data, about driving performance and everything, terrains, and you can use that in the future maybe to optimize the driving experience more. Another advantage I want to point out there, and we're going over a lot of them very quickly now, is that there's going to be less downward force each one from the weight of the car. And this means there's less wear and tear on each individual motor, which means you can make each motor less strong, making them cheaper, and they can last longer and less likely to break. So another advantage of this system is that there's going to be less gear wear when you don't have as many complex clutch mechanisms for turning the wheels. Not only will you have less gears for everything else, and that the wheels will be used less, the gears will be used less for turning mechanics, which means less wear from different fitting stuff. And turning mechanics can put a lot more wear on wheel gears and make them more susceptible to problems if they're messed up. And so there's going to be less heat on them, because they can cool faster. Now, kind of the last big one for this section is you couldn't have a broader range where this whole thing is optimally performing. And by that I mean is every electric motor, even though they run fairly over the whole range they run, has an optimal peak of performance for speed and power, everything. Now when you have 4 different motors, you can make that optimal with small motors a wider basin or flatten out so it loses less energy in a peak. But also you can mix up the front motors to have them more running at an optimal and the back motors running at an optimal more. And with the different combinations, you can make it a much broader range where all the motors together are optimal. For example, you can run the front motors at a less than optimal with putting more power, but then you can run the most power efficient on the back ones, or something like that, some combination. So each of them can be more at the optimal performance peak. Now, some other ideas that I have covered in the past, and I just want to point out there, is you can have ideas where you can tilt the wheels for more optimal efficiency for turns and stuff, and with less gears and stuff and less weight on each wheel and less mechanics, that's easier to do. You could slide the wheels, so when you make a turn, you can slide the wheels more inwards, which will make turns easier, like bouncing on a tricycle compared to 4 different wheels. This can make adaptive suspension more easily when you have less stuff hooked up and all connected for it. And you could even maybe include a middle wheel for making turns or for more stability, where you pull up the front 2 wheels or something and you just bounce the front and the middle wheel to help for better turns. Well, thank you very much for listening. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Also, if any ideas for future videos, comments, or suggestions, please leave in the comments section below. Again, thank you very much. Goodbye.